Turn on noise. Fanfare. Excited.
Yeah.
So just to let you know, in case you had any crazy ideas, this is being live streamed on Twitch right now. I know, right? So we're just going to game the whole time, right? We're going to play Fortnite, and I'm going to beat him. For those of you who don't know, we actually have a Twitch channel, which is remarkably popular. I don't watch Twitch too much. My kids do, but hey, I get it. It's the cool thing to do. But we're going to be Twitch streaming tonight because we're playing around with ideas. Like, not everybody can show up to a meetup. It's not easy, and you may be. What if you lived in Sacramento? Is there anybody from Sacramento?
Let me ask.
No, don't. I don't want to speak badly, but you know, it's Sacramento. Who has a meetup in Sacramento? Nobody, right? So we're going to invite you. Welcome, Sacramento person. Or Lodi. Who's going to be there from Lodi? The guy on Twitch. Hi, Lodi person. So okay, so you're part of our studio audience. Well done. This is going to be like a taping of Conan O'Brien. So we'll show up the laugh track whenever you have to laugh. Not really. So tonight we're gonna have two talks. We're gonna start out with Cedrick. Hello, Cedrick.
Hello.
He's been doing a lot of work with the reactive part of our new driver, and it is very interesting when you're doing asynchronous programming with Cassandra. Changes the game quite a bit. We had a long talk about it today, and I'm actually going to change some of my code now. Thank you very much. This will be very interesting, and then I will get up here and tell you 5 ways to make your database, your data model awesome. And if you don't want to hear me talk ever again, you can leave. But I'll be sad. But I'll let you take it from here.
Okay. So thank you. Good evening. Okay, you're still sleepy. So I got 3 questions for you at the beginning, as usual. So who's among you is a Java developer or is using Java? Okay, Alf. So you will see a lot of Java code in this presentation. Don't be afraid, just simple Java code. And for those folks who is using Java, who is actually using the Cassandra driver? Okay, not that many. So Cedrick Lunven. I'm a developer advocate at DataStax. I'm French, based in Paris, lucky me. And as developer advocate, we tend to provide you tons of content to make you succeed with Apache Cassandra. Can be training, can be reference application, sample code, getting started, academy.datastax.com, a YouTube channel, live stream on Twitch, and many things. So at the end of the presentation, I will give you a million link just to get you all the slides and everything you need to exactly do the same things I'm doing tonight. So this is my day job. And at night, I put my mask, my boots, and my cap, and I become an open source developer. So I created 6 years ago an open source framework named FF4G, meaning feature flipping for Java. And the goal is to enable or disable part of your application at runtime without restarting. And I'm also contributing to another open source framework named GHipster, which is you provide that tool your entities and relation, and it will generate for you a full working application, backend Spring Boot, frontend JavaScript. You can choose among Vue, Vue, React, and Angular. Angular 8. Oh no, 8 is outdated already, right? It was released last week. Okay, so tonight introducing the driver 2, what I changed, and then I will go into the reactive stuff. So I've created the same service in 3 ways: synchronous, asynchronous, and reactive, and we walk through them each time a demo to explain what changed, what are the limitations of each approach. So first, driver 2. Okay, so I will go fast. So if you don't use that much the driver v1, I won't go too into the details what changed against driver v1, but here is a SQL session. So we get rid of an object called a cluster and cluster config. So now everything is handled in the SQL session. It's auto-closable. That means it will close by itself. You need to have a single SQL session in your own application and do everything with this object. Then each time you need to access Cassandra, you will create statements. It's not new. This is our simple statement. And you will execute the statement, get a result set, and pass the result set. Okay? So far, so good. And today, yes, today, we just released something called an object mapper, which allows you to do some mapping between the tables in your database and your own objects. So I don't lie to you. If you look at the Maven Central and go for the mapper, it has been just released today, which is nice. So what can you do with the mapper? Well, I don't have a sample code, just a couple lines of code for you. But as I told you, just define your entities, put some annotation, define the name of your service and what you want to achieve, create a mapper, so no code, no query, nothing, no SQL, just code and annotation, and then you will be able to execute queries, run queries, and map from object to your tables. So I will now switch, first time switching to code, and I will do that a couple of times tonight. Okay, so this way. Okay, so in the driver, you expect to have some contact points, port, local DC, key space, and which is something's new with driver 2, you needed to provide a conf file. And the conf file is in OCon format. And you know what? The first time I saw that file, I say, oh, what the hell? What a new configuration file? Yet another config file, and I don't like this syntax. So hopefully from 4.0.1, we provide a way to inject configuration from anywhere using a configuration provider. So if I go there and see there is a new object called programmatic driver configuration loader builder, it's so long name it could fit into Spring framework actually. So you got here the way to inject the configuration into the driver. And what we do is just picking the information from this file. Okay, so once you inject all your properties to start up the driver, you will define your queries. So I just created a couple of statements here, as you see in the first slide. So those are simple statements, nothing new. I will use, something called a schema builder or a query builder to get my statements. And which is nice with this code is not only we created the simple statement as bin, Spring bin, but later we also define the prepare statement as bin. So even using Spring, we just prepare the statement. It's a nice trick to do. And once you get all your statements ready to go, then we will start to work and we invoke these statements using sync, async, and react. So if I go back to my slide and say, what about synchronous? Okay. What are the sweet spots of Apache Cassandra? These things will help me to choose the use case I would like to show you. So first time, Cassandra is distributed. There is no point to install a single node. Data is distributed among the node, and data is replicated among the node. And there is no master. That means you can lose any of the node, and it's still up. So it's always on. Pretty hard to kill. Second sweet spot is the scalability. You all know me, or maybe not, but in a single node of Cassandra, you can go up to about 3,000 transactions per CPU and per second, and with about 1 terabyte. And if you need more throughput, add new node. And if you need more capacity, add new node. It scales linearly. And last but not least is the global distribution. And maybe you heard about this use case lately in the news or something. You may install that data center, that ring, one in AWS, one on Azure, one on GCP, one on premise. And all those nodes will communicate to each other. You can write anywhere, read anywhere, and the data will be replicated for you among the different nodes and different rings. That means you can go hybrid cloud, multi-cloud easily, same database, same data layer everywhere in the world. No more duplication on your side. No need to fancy moving files or something. So in the reactive world, we most of the time speak about speed and throughput. So the scalability is the thing I would like to dig. So scalability can be volume and can be throughput. Here I will dig into throughput and what base use case that time series to have a huge throughput. So I won't show you a lot of SQL tonight, but this is the table I will work with. So this is a stock table, symbol, value, date. Symbol is the partition key because I want to get all the stocks information coming from a single symbol in a single partition. And I use the date as a clustering column. I put that date as desk because I would like to have the latest event first, because I would like to draw some nice curve based on a symbol. And as I work at DataStax, I just add a little bit of magic. So default TTL and a compaction strategy fitting the NoSQL, the time series use case. Okay, so what about the application now? Okay, so if I put Cassandra on the right part and my client want to invoke on the left, in the middle, this is the application I built for you, and it's written in, no surprise, Java, latest version of Java. The driver, again, no surprise, it's the DataStax driver, driver 2. I expose my service as an API, a REST API, by the way, and all the glue, all the framework inside is Spring. I already speak about Spring 2 or 3 times. And when I need to invoke those applications, I will simply create a unit test using JUnit 5, which is the latest version of JUnit, and some Spring classes. So let's go with the first implementation of our service. Okay, so I just close that. So this application is a multi-Maven, multi-module Maven project. That means I will have multiple implementation. I will provide you the source code anyway. So first module is synchronous. If I go to the lower level, it's a repository. Here I got all the statements I just defined in the command part just before. So they are injected. That means they are just imported at runtime. And if I want to find all the symbols in my table, well, pretty simple. I will use my prepare statement. I will bind, get a bound statement. That means I will associate parameter with some question mark in the query. Execute my query, get my result set. And then, trick, I would like to do some paging. I would like the record from lower bound to upper bound. So I just put my result set as a stream, iterate, and find the first and the last using a limit and skip. You know, it's part of the stream API. Pretty easy to do, start and end. And for each single record, I will use a mapper to find my object. And if you noticed before, now we got the object mapper from today. So I won't have to do that anymore from today. But I didn't change the code yet, just released. I told you it's very pretty recent. So this is my repository, and on top of it, I will create a controller. So it's a REST. I reuse the Spring REST API. And if I go to my list symbol, it's straight to the point, invoke the DAO, get my stream, return my stream, and that's it. And I do have a small test for you. I can run that sample. First demo, finger crossed. Here we go. I don't want everything. I just want my small stuff. Here you go. I just want my find stocks when run as JUnit test. It's not like I did that 20 times today. Okay, here we go. And if we go to DataStax Studio, which is a nice web UI to work with Cassandra, I can see that I should have my stock table field and my key space demo and stock table field for me. Okay, so that's sync, and that's pretty easy, straight to the point. So what we just see? So first, when we initialize a connection, it's always synchronous. And later today, I will switch to asynchronous and reactive. And each time to initialize the connection, I need to execute the very same code, and it's synchronous. So at startup, you may lose some seconds, but later you will, of course, gain a lot of speed. And for the result set, well, we initialize the statement at the beginning. There are parse, and if you make a mistake in your SQL statement, you will see right away at the startup. And afterward, you will just push the parameter to the Cassandra node. And on the Cassandra node, you will have already all the the context prepared to execute your query, and you won't have to pass the full query, only the parameters. So those two things, synchronous. Okay. What about the service? I'm invoking something. I'm passing the parameters, bind, invoke Cassandra, go back, get my result set, parse the result set, get my result. And finally, we get the result. All that time, the customer waiting for the records. And we need to wait up to the end of the query to get the results. So this is not what we want, right? Even if synchronous is simple, easy to test and maintain, a simple browser, and you're ready to go to execute your service, well, as you can see, it's blocking. And you lose a lot of time. And if it's blocking, you're blocking some resources, disk, CPU, whatever, and you cannot scale up as much as you will. So first approach will be to switch from sync to asynchronous and see if we can get rid of the blocking and the scalability issue. So I get my services. I want to put that services async. Which technical stack will you pick to expose an asynchronous service? GMS, AMQP, Kafka? No. Okay, from GIX RS 2.0, REST is already asynchronous. So you don't need all this fancy Kafka cluster to make a simple async service. It's working out of the box, just using some annotation to make the service async. It works both for the service and for the client. Yeah, so no change. And let's see what we did with the code. OK, demo number 2. Let's go to Eclipse then. OK, so module number 2, async. And I will show you first the repository, the lower level, way to access your services, find all symbol, and I bound, exactly the same as sync. But now I have the execute async method, and I won't return a result set, but a completion stage. And only when the stage is finished, complete, then I will compose to get my stream and row mapper. And I need to find a range of record. I put a limit, start and end. But now everything is async, so I don't know actually when I will get my last element I need. Maybe I will go over multiple pages before I was able to get the number of items recorded. So I need to create something called a row collector, which is something like that. So I need to count by myself to know if I got enough information. Yeah, of course, I don't have the stream, I don't have the skip and limit method anymore. I need to do it manually by myself. But it works, but I do it by myself. So now if I need to create a REST API on top of this completable stage, well, let's see how it looks like. Controller, async, and OK. I just want to show you. OK, so and then I get my completable stage. You might tell, OK, pretty easy. But what about error handling? Let's say now I would like to update something. OK? So now I would like to find something. If I find it, I'm happy I will use the mapping. But if I don't find it, I need to go and do some exception. But if it's not there, I need to create it. If it's there, I need to update it. And this is what it looks like, right? So I think it's pretty nice, pretty fun, pretty fast. But this is the kind of source code you are coding. Nice. We love async, right? OK, so if I go back to my nice slide deck, what did we see? This is async queries. I put my parameter, I bound, I execute, get my completed stage immediately. I don't wait anymore. And only when the result is ready, I get a notification for each page, because each request is always page. We always use paging in the Cassandra driver. So when the first page is ready, we get back with the result, async result set. And we're happy. Yeah, it's exactly what we wanted. Only little small problem you might have seen. It's pretty complex to handle. I mean, to execute and get all the results in the proper order. This is what we call the callback hell. So many nested calls, so many complicated code. And so, yeah, async look pretty nice because now it's not blocking anymore. And we can scale, pretty happy. But we introduce two new weaknesses. The first is the callback hell, and the second is maintainability. If you have a new nested call to put in that crazy source code, what will you do? It's pretty hard to maintain. So what will you do? I'm pretty sure you guessed, right? We will do the reactive approach. So what is reactive? So reactive is based on a specification, the reactive manifesto. You can find on reactivemanifesto.org. And so the purpose is to create some applications that are maintainable. Oh, this is exactly what we want to do. Extensive, you can add as many features as you want. And responsive. That means it will always respond something in a predictable time frame. So that means if you get a lot of load, the application should be able to scale. And this is the elastic part. And if somebody goes wrong, well, the application should still be up and running. And this is the resilient part. So we can use some circuit breaker, graceful degradation pattern. But when you're using reactive stuff, you need to handle all that limit use case or all the error. And to be able to be elastic and resilient, we need to reuse the well-known message-driven pattern, loose coupling, async, accumulator, all the things you saw. Okay, so how do I implement this reactive manifesto? Well, somebody did that for us. So there is a specification, and it's called Reactive Stream. So it has been released. First release was 2.15, and it has been created by Netflix and Pivotal and Lightbend, more or less. And so we define two roles. First, the publisher that will emit some event, and a subscriber. I will subscribe to the publisher, get back, subscribe, and start to get some request. And for each result, I get a callback. So now it's not a callback per pages or per result. It's a callback for each single row. Some reference application in the Java world for Reactive Stream. Notification for the incomplete. Now to implement that stack, I need to change a little bit the way we expose the service. Because in the Spring Boot world, if you don't provide a fully non-blocking application, then it won't even start. Spring will tell you, oh, your endpoint, REST, seems to be blocking. So I won't even start. There is a single loop in reactive, and if somebody blocking that loop, everybody is waiting, so no wait anywhere. So to export the service, we move from Spring Web MVC to Spring WebFlux, which is also a pretty new framework created 2 years ago. And we invoke that reactive stuff using Spring WebFlux, new classes, and again, JUnit 5. Okay, so let's see what happened to our code. So Eclipse is this side. Okay, no, I don't want to save. So let's go to the reactive world. So let's first use our repository, low-level API. Okay, so now we bind exactly the same as before, and we use execute reactive, and we don't get any completable feature or completion stage. We get a reactive result set, which is the publisher of the reactive implementation we just saw. And so we will just create a flux from this result set, and it will be a flux for reactive row. And you get a notification for every single row in your result set. And you know the good part? A flux is behaving the same as a stream. It got the same API, the same method. So now, to be able to do paging and get items from offset A to the limit, you can reuse the skip, and it's not called limit, it's called take. And just like that, the reactive framework will do all the things, all the weight under the hood to be able to get the item you need. It's not really waiting, it's just accumulating to the result. And get the mapper. So that's it for the low-level API. What about the controller? Let's go to the controller. And here we go. And you know what? It's exactly the same controller as the synchronous implementation. Now there is no more callback L. You can just handle that the same way as we did before using exception, and no more callback L. We just simply save, map, reuse the same Java Lambda as we get used to do with the synchronous way. See, find all symbol. There is absolutely nothing to do. and we even reuse the same annotation get mapping. And it's reactive, and it's async. Pretty nice, right? Okay, so when you use the reactive stack, okay, you put the parameter, prepare statement, bind, that is the same. When you bound, you get first the reactive result set that we change into a flux. We start to execute some requests just after doing the subscribe. So we execute the query and get a row, which is here a reactive row, and we got a row for in notification for every single row. And once we're done, we get enough results. We just send the incomplete. Yeah. So you might ask, which framework do we pick to implement the reactive pattern in the driver? Is it RxJava? Is it Reactor? Well, not at all. DataStax just re-implement the reactive stream. There is something called the TCK for Test Compliant Kit to know if your own application match with the reactive stream specification, and that's it. That's it. Exactly what we did. So when you read a lot of data coming from Cassandra, as you get a notification for every single record, we can say, oh, my subscriber, which is here my client, cannot keep up with all the notification I push to him. So I can tell to Cassandra, whoa, please slow down, just to help the client to consume all the events. And you got an embedded back pressure mechanism, which works on the read side. But on the write side, unfortunately, you cannot just ask your client just send you a lot of event, especially if you are working on event sourcing model. So eventually, you will just get the default behavior of Java, which is everything is fine until it failed. So at a point in time, you may get some exception, overloaded exception. But yeah, you know, Cassandra scale, so eventually, if you hit the limit of Cassandra, add a new node. So now with the reactive stuff, not only we are simple on node blocking, but we are scalable and maintainable. As you can see, the code is very close from the sync way to implement, and it's still async, it's still fast. But we didn't get rid of all the weaknesses. Again, new appears. First is it hard to debug? Because now, if you do some unit test, you will have to block or compare the result only when all the rows have been processed. So you cannot stop in the middle of the call to say it's not working anymore. You need to get all the results to do the comparison. So you need to be aware to handle all those use cases. And the last threat is the overloading exception. There is no back pressure when you write. So eventually, you can have the overloaded exception. But I just say in the beginning, 3,000 transactions per CPU per core. Now most of the machine have 8 CPU, is 20K transaction per second and per core. And you know, most of configuration is 5 node. So it's about 100K per second, which is already pretty high for a basic use case, right? So about all the links, this is the only photo you need to make tonight. So a lot of links. So first is a GitHub repo where you find all the source code. Second is DataStax Academy, academy.datastax.com, where you find all the training to improve in Cassandra. This is a new website. Again, all new stuff. We just launched at the beginning of this month. It's called community.datastax.com. If you get any question on Cassandra on DataStax, go here, ask question. It's free. We are experts. We answer question. And below, YouTube channel, Twitch channel. Hi, Twitch. And download DataStax. We also provided some labs and beta version of everything's new and everything's coming. So you got DataStax desktop, you can install on your station. You find the new version of DataStax graph and all new tools that's coming at the end of the year on GA. Thank you. Question? Yep.
Yeah, I had a question. Do you have the mic or?
No, I will repeat the question.
All right, so when you showed the reactive model
Yep.
with the reactive row, it was not exactly the same use case as your async, right? You're doing something on complete, you're doing error handling.
Yep.
But I didn't see all that. So in some way, you still have the callback, right?
Yeah, you have the callback for every single record. In the object reactive result set,
Yeah, so
it's a subscriber.
So if you have to do error handling or if you have to do something for a particular record, still you will have the callback on callback on callback, isn't it? So you'll
No,
still
because
have the chain.
you will process all the, everything related to a record in the single callback. Why do you have callback of callback? It's not the same as async when you need to handle multiple things. In async you get a full page, and depending on the page you can have multiple error, and so depending on the error you get another callback. So multiple branch in the same callback, because in the callback you have multiple record. But now on reactive you get a single record, so you can just decide it's true or false, correct or not, exception or not.
But you still have callback.
You still have a callback which is hidden here. It's not
Different from the way you write an async.
Yeah, it's now a flux. It's not a completable feature. But you know what? You can just get a completable feature in Java 8 and move it into a flux.
Yeah, same thing. You can change
Yeah, but if you move from flux to completable feature, you lose all the incomplete stuff and all the nice, pretty features you get with the flux. But yeah, you still have callback, even more callbacks.
I had one more question. So on that DAO that you've shown,
Mm-hmm.
right, and you created beans, and I think you have a SQL that you were trying to inject, right, with
Yeah, so
limit.
it's not really so all the SQL statements have been created with the query builder in the common part, something like that. So everything has been initialized at the beginning. So I now create something using SQL identifier, which is immutable. And then for my statement, I will just say query builder, maybe this one is okay, .insert2, reuse all the SQL identifier just to create my statement and get my prepare statement.
Does it come with something inbuilt for the primary key? Because it already knows the primary key, and
Oh,
most probably going to find that primary.
that with, okay, this one will generate, so query builder insert will generate a SQL statement. Just insert into. There is no notion of partition key when you insert into. You need to be aware of your partition key, and if you don't provide your partition key in the insert statement, it will fail. In the create table, yes. Here, I create table, so new statement, create table, and I will say with partition key and name the column.
Asking for find by.
Oh, find by. Oh, it's just me who knows which is the partition key, and I create the query accordingly because I know which is the query.
We should have lookup over there, right?
Yeah, so if I do find by ID, it's me. Okay, find by symbol. This is my.
I need to monitor this big, I think. This is great. Although I think I would break my head. It's like, what's going on over here? Over here.
Yeah, so this is my simple statement. This is me that's putting the where clause because I know my partition key is part of this where clause. But it's a good point. In the object mapper part, which has just been released today, if you look at the simple, in the beginning, of course it in the beginning, then you just annotate your entities. Here is the partition key.
That's what I'm asking.
So
I already know that.
if you do that with the mapper, then when you do the save and the insert by ID, he knows, oh, by the way, we got an issue here. It's a face sample. Yeah, we should have the UID here, and get exactly the same. But he will notice, depending on the annotation, but it will generate exactly the same statement as we did explicitly using simple statement.
Thank you.
All right.
Nice.
Thank you. I need to borrow your stuff, okay? So I'm going to borrow this and this.
Yes, please.
And wow, is this our Twitch setup? Is this what makes it work?
Yeah.
Is this all the magic right in here? Right in one box? Hey, can I use your clicker too? Cedric?
What did you say?
Can I use your...
Oh, the clicker? Yeah.
Where is that?
I will give it to you. What about the mic? Oh, you already...
I already have one of those. Can I have your presentation?
Yeah.
All right.
Do you want my code as well?
Yeah, can I use your code?
Do you want me to present?
Yeah, can you do the presentation? All right, what am I even up here for? All right. Oh, I can't move. All right.
No, stay here.
Yeah, apparently. Yeah, I was really nervous. I mean, we have... oh, my laptop. Oh, you can't see the DataStax logo? Got it. All right. Yeah, we can't have that. All right. So, welcome, everyone. What's that? Am I not? Oh, God. Noel, you got like all these people helping you. It's great. You don't see this behind you, but there's like 5 people back there. All right. Does she look good? Everything's fine there? All right. We're good. Okay. Because, I'm really worried about those 3,500 people who are on Twitch right now. It's amazing. And welcome, everyone, from far-flung places. I actually heard that the International Space Station is watching this right now. Yeah. So... a lot of people want to know about Cassandra in space. Why? Because it's the only database that will run in space, and we're going to prove that someday. Mark my words. I have a plan, and I've been trying to pull it. I talked to our CMO about this. I say, look, I have a crazy idea. Give me $2 million. Trust me. And she didn't say yes yet, but I'm working on it. I want to put some CubeSats in low Earth orbit, all networked, and they will work. I want to put a cluster in space, because Microsoft, where they have Cosmos DB, whatever, it runs on Earth. I'm going to show a terrestrial. What is that? No, I want one in space. And I'm pretty sure it will become the official database of SpaceX, well, it'll be hard with Blue Origin. Jeff Bezos will have to finally admit Cassandra's better than Dynamo because it doesn't run in space. All right. I'm sure this talk has nothing to do with that. just giving you my dreams, just letting you know who I am. All right, so how many of you, I see some familiar faces, but how many of you use Cassandra on a pretty regular basis? All right, I knew you would. you walked in and said, oh, you're here. Yeah. Well, good. There's a lot of not hands up there. And so I'm going to give you a pretty quick run through. Now, this is going to make you extremely dangerous with Cassandra data modeling, but it'll give you a good overview of what you should know, how you should understand a Cassandra data model, and hopefully give you enough information that you can move on from there. So let's start with where you begin. Everybody does this, right? I have yet to find out, is anyone here not using relational data or doesn't know anything about relational data modeling? Still no hands. See, this is going to be the case for a long time. Although I did get one hand at a university. So they're like, oh, we never use SQL. Oh, wow, it's starting to happen. But we're not there yet. So relational database, you have your 5 normal foreigns. No one gets past 3. You have foreign keys. You have joins. This is what we build. And when you build tables, you're joining them together. You have your employees and your departments. This is what we're used to doing. And then you build these things. What are ERDs? You know these things really well. You've probably prayed to them as you wrote your application, right? Because where's my data? Well, you got the little crow's feet here, that show like one-to-many relationships. So entities and the relationships, now that's SQL, right? No, this is not SQL. This is an entity relationship diagram. So relational data modeling, you take that ERD, which isn't your physical data model. It doesn't say anything about the SQL itself. And you create an entity table, you add constraints, you put your index fields in there, you add some foreign key relationships, And this is, I mean, I was an Oracle DBA for 15 years. I did this in my sleep, you know? This is how we build those. And that foreign key relationship is maintained. So whenever you do a delete cascade, and then, you know, the redo logs fill up and your DBAs call you and freak out. But that's what this is for. So you wind up not creating problems. The problem with all this linking and connecting and everything is this runs on one server, right? And it is pretty heavy. ACID compliance is hard. And what I think we've all learned to do is we take this domain of data and we create models from it, and then we write our application. And our application adheres to that data model. Here's what I am ready to say this because I don't think a lot of people believe me. I was just at the Velocity conference, maybe you were there too. I was just in San Jose a couple weeks ago, talking to folks about, did you know, and I'm going to make you believe me by the end of this, that almost every relational database use case can be moved to Cassandra? Oh, I saw somebody's head. Don't walk out, stay here, I will prove it to you. And this is even things like banking. Oh, this is one of my favorites. Well, banks use relational databases. No, they don't. Banks don't use relational databases for transaction management. You know what they still use probably? A mainframe or Cassandra. So how does that work? Let me explain. So Cassandra data modeling flips this data modeling scheme on its head. You go from an application, I'm going to build an application. You build the models to match that application, and then eventually your data comes out of it. And that is completely on its head from what I showed you before, where you take that domain of data, build your models, then the application. And this is what we call application-based data modeling. That is how you build data models for Cassandra. So I'm going to give you a quick example. We have this reference application called killervideo.com. I would recommend you go check it out. And the reason I think you should check it out is because it gives you some nice, there's a tour. Click on that button, and it'll actually walk you through the application and show you the data models that are there to support the application. That's kind of cool. And it gives you some real world. This is an actual running application, and it's really running with Cassandra. And it's kind of like a YouTube clone, and you're going to see some cat videos and everything. We totally stole it from YouTube. But that is just a simple system, but you think about it, this is a system with entities that requires transactions, that it requires all these things that a relational database typically would be used for that Cassandra can do really awesome. You know what else you get with that is multi-data centers, hybrid cloud, multiple clouds, no problem, active, active, active all the way across. And this database is built to scale and replicate. Unlike that wonderful relational database that everyone seems to still hug, you know how Oracle scales? Right up until you run out of money. All right, so, thank you. My reps always hated me telling them that. All right, so building an application flow. We're going to start, we're going to do 5 steps here. This is not 12-step, this is 5-step. Building your application workflow, step 1. Now, this is probably where most people, most application developers get a little tweaked. They're like, hold on. I don't know my application workflow. You probably do. So this workflow, what am I talking about? In the conceptualization phase, when you're doing the whiteboarding, you know, the fun stuff you do with the product manager and the architects and the developers, and we all get in a room and we have pens and we start marking on the board. And there's this conceptualization phase, like, what are we building? It's a part of our product, or it is a product. Well, during that moment, and when you're doing that, and you've probably all done it, you go through this thing where you mock up pages and you start looking at how your application will work. And things like user will log in. There's a sign-in button up there. These are all pretty common, right? But you'll learn things like, oh, user selects video. These are parts of the application that I need to be able to support. Now, what we can build is this thing. It's called an application workflow. And it's very simple. You don't just show the basic information about a user. You just don't, you can, but it's not something you're going to ask in an application. You're going to require a login first, right? So you're going to have in state, you're going to have who that user is. Same with showing about a video and its details. Either you're going to click on a video with like an ID number on it, or you're going to do some sort of a search to find it. So all that stuff is part of that workflow. So you're not seeing as like, well, I need to be able to write any random query I need at any point, that's SQL, where I'm going to track all of the queries my application needs and build those. So that's the next step, modeling those queries. Now, when you have a pretty decent workflow, good. But let's go back to this. This is an entity relationship diagram of killer video. And this should be really familiar. This is the same thing. Entities, user, video, comment. Those are all entities. And I actually heard somebody tell me, you can't do entity management with Cassandra. I'm here to tell you that's all it does. And those entities have relationships, and they have properties. This is what a database should do. You shouldn't be able to just dump JSON in it and expect for the best, right? Let's model our database. So how do we manage that? Look at some, like, I have requirements. User logs into site. OK, that was one of the things. Well, the query that I'm going to map to that is find user by email address. That's how I'm doing my user management. How about comments? Show comments for a video. Find comment by the video or the ID of the video. And I have a requirement that I want the latest first. So there's a reverse order on the timestamp. So all of these things I'm starting to pick through. And now I have a pretty good idea of what my data model should look like. Now, I'll pause you for a minute. There are some that require a little more finesse or a little different type of data model. For instance, something that is more like an index, like find video by tag. Now, normally in a relational database, I would maybe index the tag field. But if it's a collection, that's going to be really hard. I'd probably have to add some sort of a search mechanism to it. Well, in this case, I'm actually creating a physical table on the file system or on the database that will index all my tags, like the cat, funny, laughable, all those different things that how we tag videos. So I'm going to walk through these. And now we're ready to actually make a table. Making that table is going to be somewhat familiar. So you take the users, that's you, and how you name those, and this is my personal naming scheme, but one that I hope many of you will adopt, which is entities. You give them a single name: user, comment, video. And then we have these relationships that we also create tables for the relationship. That's a big one. We create tables to build the relationships. It's not a foreign key like a join. Now this table is actually the join. So in this case, find comments by user. So I'm going to give these some very descriptive names, and I'll show you in a minute what those look like. Now, a static table. I want to find video by ID. Well, here's the videos table. And I say this should look familiar because it's a create table. This does look a little bit like SQL. So you have a table name, some column names. You have data types. It's a CQL data type. CQL data types are CQL Cassandra query language. Data types are very important. They do a lot of things. First of all, they marshal the data. So if I say UUID and I throw a number at it, it should bounce. It shouldn't allow that. It enforces schema. But also, it does things like does sort order if I need that. It maintains that sort order. Now, what it doesn't do, and you'll notice, like varchar doesn't have a size on it. How many of you can type varchar 255 in your sleep? Well, it doesn't allocate size. And that means that you have a lot of flexibility when it comes to the storage. The storage actually is 2 gigs per column. Don't do that. That will ruin your application. Trying to stream 2 gigs of data from your application to the database, your network people will find a place for you to be buried. That would be really mean. But you do have some flexibility. You're not going to get capped on size. But that means the data that you put into your database is what you actually, that's the storage requirement. Whenever you do a create table in Oracle, for instance, it allocates the space on disk. Same with MySQL, all the relational databases, because it's a random access file. You have to create the segment on disk. And this, as you're writing data, it starts using disk. And that's really easy for scaling, and that helps you. You can do scaling exercises very easily by just looking at the data types and what you're going to store in the database and do some simple math. Now, finally, we have the primary key designation. And this, I will argue, is the most important part of the data model. This is the part that I really want you to take away tonight and say, aha, I will make sure I know how to use a primary key. Primary key has the same use as a relational database. It says this record is unique based on that primary key. In this case, it's this one thing we call a partition key called video ID. So this is a single ID lookup table. I will say select from this table where video ID equals whatever that UUID is, and I will get that entity back. That's what this table is for. Now, a more dynamic table is something like find video by tag. Well, this create table of videos by tag, now that's a little more interesting because now our primary key is going to change. And as I said, the primary key is probably the most important part of this. Here's why. Because it's not just a single partition key lookup. I'm not looking up just a tag. I'm also including the video ID. Now, the first item in a primary key is called a partition key. Every other column that you add into it is called a clustering column. You could think of this as a way the partition key is used to allocate like where it is in the cluster, and the clustering columns allocate the storage. They denote the storage. We'll go into this, but this dynamic table then allows you to store all of the video IDs for that one single tag on one file on your disk, ultimately. And it makes for a very fast lookup. These are millisecond lookups at this point. So whenever I do users, I have these two things going on here. Like, for instance, I'm going to find the user by email address in the user credentials table. And then as part of my application workflow, and this is just to demonstrate the workflow, the next step in my application is I will take that ID that's returned from this table and then do a lookup on users when I display the next page. So mobile application, web application. I hope no one is making CICS applications anymore. That would be terrible. But those are typical. You have a workflow with your user interface. Now, number 4, get the primary key right. I said it was the most important thing. Here's how I'm going to prove it. Primary key. Again, that part of your table declaration, which denotes this is going to be this is a unique part of a record. That first part is a partition key. The partition key has a very important job. And now, since we're no longer talking about a single server. Good. That means you no longer have a single point of failure. Now you're using a distributed system. All right, now you have to understand how distributed systems work. And this is as much distributed systems as I'm going to give you tonight, but it is a pretty cool topic. I have a whole degree in it. But the idea of distributed systems is that you have locality of data, that you have multiple systems, but you want them to act as one. So when we create a cluster of, say, 1,000 nodes, and yes, there are 1,000 node clusters out there in the wild. Some of us here work at that place. I'm not going to point out names. Anyway, when we have a 1,000 node cluster, you run into two problems. First of all, you're running 1,000 nodes. Second thing is, where's my data? Now, if you were looking for select name description from videos with that UUID, and yes, that's a UUID, what are you going to do with that? Now, if you're looking at this cluster and every single node, a full cluster scan really sucks. Okay, that's a Spark job. That may run overnight. So 1,000 nodes, no. The partition key, which is required in a select, what it does is it gets tokenized. It gets hashed into a consistent hash. And that actually is mapped to a single node and its replicas. So that partition key is really critical for finding where that data is. So in a 1,000 node cluster, that video ID, that record, only exists on 3 nodes because we have a replication factor of 3. If you have a replication factor of 4, then it'll exist on 4 nodes. And that's it. It's like the address of your data on that cluster. And this is what makes for fast data models. The dynamic part of this adds a little more to it. So I have a partition key tag. So if I'm looking for cat videos, those are probably going to be listed on one node. So that gives me a locality. But then I have the video ID, which is something that I want to show like a whole string of. Now let me show you how this would work. So the partition key and the clustering column. The partition key would be like a tag would be data model. But the clustering column is actually a record after the partition key. And this is how it's stored on disk, but this is all a logical arrangement in the storage system. Why did we have it like this? Is because we want to do fast lookups on partition data. And so you use the partition key to find out where the data is in your cluster. You use the clustering column to create order. Now, I need to change this example because UUID is not sortable, really. It is, but it isn't. But think of that, something like a date or a number. Dates are really popular. If you're doing an IoT application, for instance, being able to create a partition key with, say, like a device number. This is very common in fraud detection. And the clustering column would be the date stamp of the data that you got from it. And you can change the order on disk, making ascending or descending. That makes for some really fast data models. All right, finally, now that we've departed from primary key. And primary key, there's a lot more to say about it. But right now, we're just going to move on to something that's also pretty critical, is using data types effectively. This is one of my favorite things that when people talk about, oh, NoSQL database, no schema. Right on, I can do whatever I want. Wrong. There is schema in Cassandra, and you have to adhere to it. And it has type. Typed databases are awesome. And data types do two things. Like I said, they do data marshaling. Hey, is this the right data type? I'm enforcing the schema to my application. Our drivers all enforce that as well. Get string, set string, all of that is baked in from top to bottom. So now this is good for the DBAs, this is good for architects, this is good for developers, because everyone agrees this will be a string or this is an int. Now, the order controlling is probably the thing that's where you get into some really cool like ninja skills when you can really do some cool stuff with ordering and clustering columns. And the ordering is controlled by the types. So I'll move on. The ordering, these are ones that are really typically used for order. Like int, obviously, you want to do numerical, ascending, descending. Date, timestamp. Now time UUID, very special data type, which is, does two things. First of all, it's a UUID, which is a universally unique ID number, which is guaranteed to be a unique number in the universe. It's kind of in the name, but I'm sure there's plenty of people who argue with me. But anyway, it's meant to be a random number hash that is going to be unique, but it adds a timestamp as part of it. And that's pretty cool because whenever you're doing something like really high resolution IoT, and there's a potential where you have two timestamps that will intersect, the way that Cassandra works on inserts is that if you're trying to match, like your primary key includes a timestamp, use a time UUID if you have high resolution. Why? Because if you're using a primary key and there's two exact same data points, that are the exact same value, it will overwrite the previous value. As a feature, you could turn that off, but now you're affecting your speed. More than likely, you just want to store both values. Time UUID lets you use the exact same timestamp with a UUID component attached to it, which gives you that randomness, and you get both of them. Now, time UUID, since it has a timestamp in it, also has a comparable, so it allows for sorting. So when you say select and you want to sort on time UUID, it will do it in time order. And that is one of those things that will save your life if you're doing IoT. Banking loves time UUID. They never lose data. And so just keep that in mind. We really try to map like directly to Java types, and there's some special ones, but like for instance, decimal goes to big decimal, float, double, big integer. We try to map as much to the Java driver as a first-class citizen, but there's also special typing that goes into Python, C++. And then finally, collections. These are ones that can get you in trouble because I'll give you an example. But first of all, you have three different collection types. You have set, list, and map. Set is I want to, the data that I put it in, the order it goes in is the order that it'll stay in. So, or I'm sorry, by the ordering of the type. So if I say set of varchar, it will do alpha order in the set. If I do a set of int, it'll do int order, integer order inside of the set. List, I get to control the order. That's a little heavier of operation. And then map is just a key value. And again, you have CQL type for the key and a CQL value or a type for the key and the value. But here's what you don't want to do. And this is, you can nest types. You don't want to create a database in your database. And I've seen this happen before. It was like, ooh, I have a map. Now I can build a database, like a key value store inside of a Cassandra partition. there's a limit, first of all, of how many map objects you can have. You can have 65,000 of them. That sounds like a really familiar number, I'm sure. It's actually 65,536. And that's a limit for a reason, because every time you read a map, it has to read the entire thing off a disk. So that's a huge hit. It doesn't do incremental reads of maps. That may change in the future. If you don't like it, I think a Jira would be awesome. Remember, this is an open source project. Or a contribution? We'll see. All right, maybe one of the 3,500 people watching on Twitch. I'm looking at you. All right, so the map, though, is really a useful, it is a dynamic part of your data model inside of your data model. And it is useful up to that limit, of course. But you can create a list of maps. I mean, you can do collections of collections. So there's some really cool things you can do with it. It's a dynamic part of more of a static data model. And that is the beauty of it. It is built for a reason. It does give you some of that dynamism. So for instance, with a set, I may have a set of different images for a video, like thumbnails for a video or something like that. I think that's what I actually did here. Preview thumbnails were a map, sorry. The tags, I had a set for tags. And so it gives you some really flexible stuff in your data model. All right, so what are you going to do now? Since everyone here, except for you, has never used Cassandra before, how do you get to use it? Well, we got a few choices. If you want to just go the open source route, go to Apache or cassandra.apache.org, download the tarball. You can download Trunk, which is pretty cool. That's 4.0 Trunk, which is not released yet, so we would love to hear your feedback on it. Or run the 3.x Trunk. If you like open source, but you just want support, we have that available at DataStax. It's called DataStax Distribution Apache Cassandra. It's a support package, and we have different levels of support. Like, really, we'll call you sometime support all the way up to I want critical support on my open source systems. And then finally, when you want all the bells and whistles of an enterprise database, including security and auditing and a lot of really cool backup tools and operations, and it's a very enterprisey product. DataStax Enterprise. So we give you the full range. Now, you may have heard, and maybe not, that we have announced a product called Constellation. And Constellation is our cloud product. And part of it is this thing called Cassandra as a Service. So we have signups going right now. You can go to, what's the URL? Constellation.io? No. Constellation.datastax.com. And you can sign up, get in there, check it out. And we will let you know when we have openings for it. We're going to be releasing that soon. But this is just stuff to look for that's coming. We're really excited about that part of it because, as most of you are probably aware, running a database kind of sucks unless you are the person who gets paid to do that, and then it's awesome. And then there's one other piece, I think also, there is Docker images available too, and I forgot to mention that. So there are lots of ways to do this. If you want to know more and you want to get more information like this, like I said, this is 5 steps, but there's way more to this. Go to academy.datastax.com. We have tons of resources, all free e-learning. You can see me and David and a few other people up there talking about how to build really good data models. And there's a whole course on data modeling. There's a whole course on operations. All the parts of our data, like our operations product, Op Center, all that's online. It's for free. You can go check it out. So I think that's all I had. You have all the resources you need now. Questions? Yes?
So you said before that Cassandra can be used for transactions like in banks.
Yes.
But like I haven't used Cassandra. Like I just have used in some small projects, not on a large scale. But Cassandra talks about eventual consistency.
Right.
And what we need in banks, suppose, is like a strong consistency there.
You get strong consistency with Cassandra. What I think the myth of the bank use case is that you need commit rollback and that you need to do strong transactions where you say, I'm going to change these 2 accounts and then do a commit. No bank ever does that. And why? You can look at the back wall. We have a lot of banking customers, and they all put all their transactional critical path is probably running on Cassandra. Why is that? Banks don't need to have they probably wouldn't even trust a transaction at that level because if it fails, and MVCC does fail, then how do you unravel it? And it creates a lot of redo. And what banks have done since the beginning is computing on banks started with mainframes, right? What they do is they have this, there's a data model called a ledger data model. So what you're doing is you're tracking every single thing that happens, every transaction as like a flight recorder. So if you're, say, moving money from one account to another, transaction 1, remove money from account. Transaction 2, add money to account. Transaction 3, update balance. And that's a series of transactions. And if something happens in the middle, then you can go back and replay it. And this is how we've built a lot of systems around this. And it is kind of like a redo log, but banks don't want to lose any data. They're not going to lose the money. They don't lose money, but they don't want to lose data. So just making discrete transactions in there, now blow that up into all kinds of different use cases. For instance, if someone, like your Bitcoin transactions, I've seen a couple of those use cases are pretty cool. Monzo Bank, I don't know if you've heard of them, are all internet bank, 100% Cassandra, no relational databases to be seen. Why? Because they have a bigger problem. They need to be in multiple data centers, active. They need to be international, so they need to have their data geolocated. If Monzo, this small internet bank, went to a big company like IBM or Oracle and said, we want to set this up, they couldn't be a startup. It just wouldn't work because they couldn't afford the kind of systems. And even then, it wouldn't even match what they need. So that's why I'm pretty confident in saying that. And that's the kind of thing that we try to like get you thinking about. Is what is the real transaction? It's easy to do a commit rollback, but is that really what you need? Sorry, long-winded answer, but I thank you for asking the question. Other questions? Yeah.
Is creating a separate table for each of your query the standard way of modeling in Cassandra? Question number 1. And 2 is, what's a good choice for a partition key? If you're only talking about like one column, is having like a GUID for the partition key a good choice for the primary key?
Excellent couple of questions, and I can tell you were paying attention. So first of all, for every query, you're going to have a table. That seems like you're going to have a lot of tables. Yes, more than likely. It depends on how big your application is, but having tens or hundreds of tables is not uncommon. But you want to think of it. Actually, there's a good way of thinking about it. It's like a materialized view. You're denormalizing every single data bit into a single table. You may have data duplication. You will have applications that support various parts of your tables that support various parts of your application, which there may be many. But what you're doing is you're really optimizing the database and the application together. So whenever you create new features, you just add a new table. This is how companies like Netflix stay online 100% of the time. And they keep adding features because they do this A/B stuff where they can add things to the database and migrate data over real time and then have that feature online immediately without having to go through like alter table. Do that on a big database. I remember when Facebook did an alter table on one of their schemas, it took over a month to change. And so scale brings new problems, right? Second question you had is, what's a good partition key? And I really love that question. There's a couple of ways to do it. So a UUID is always a good choice for a lot of reasons. It's easy for drivers or any language can generate a UUID, Java, Python, any language. So that is not a Cassandra thing. It's just a part of software engineering. But a lot of times, what I try to look for is a natural key, something that, for instance, on that user lookup table, the email address. I know that should be unique, and I'm going to enforce that uniqueness. Now, here's maybe a little side subject on that. But if I'm going to have an email address, and Cassandra will overwrite my data if I do an insert on that, doesn't that sound dangerous? Well, there is a way to do this, and this is to the strong consistency. We have this thing called lightweight transactions that do an exclusive write to the database, but also do consistent checks. So you could say insert into, and it will insert into with that email address. And when you do that, it will lock the database, lock that row, do a lookup on that row. First of all, see if it exists. If it doesn't exist, it'll make sure it's the exclusive writer, write the data to the table, and then release the lock. If that data exists already, and this is the key phrase in that insert only, if not exists, if it exists, it'll turn it back to the user saying, I'm sorry, this row already exists, and reject it. So we have mechanisms inside of it to maintain a really strong consistency. But something like an email address, which is it should be unique, use that as a primary key. Now, a little more advanced would be maybe using something like what I call composite keys, which is a combination of two things as a partition key. If you use two different items, like for instance, if you have a device ID and a year that you want to use as your partition key, put parentheses around it, and that makes those two items a single partition key. So these are like some of the things you'll learn. We have a course online called DS220, it's practical data modeling. It goes through a lot of this stuff, but this is where you can get some really cool skills and impress your friends, make all your coworkers totally jealous because you know what you're doing. But that primary key, like I mentioned, that's the most important part. You get that primary key right, you've got a great data model. Yeah?
So is there any easy way to move from relational database to Cassandra? Like recently, Amazon, they have shouting like, hey, we moved from Oracle to Aurora.
Right.
So, for example, Oracle also like very expensive product. So is there any tool or something to move from relational database to the Cassandra?
I really wish I could say yes, but it's you're going from a normal form, multiple normal form database to a fully denormalized database. So no is the answer. And some of the things that let me explain some of the parts that make the answer no a little more palatable is whenever you have a fully normalized database, third normal form, second normal form, the important part is the queries that you're running against it at that point. So in order to migrate data, you would have to be watching every single query on the database. So I would, if I was migrating data from a relational database to Cassandra, I'd be way more interested in the list of SQL queries, the select queries you do, versus the tables themselves. You see why? Yeah, and so that's one thing. Also, when you're building a new application based on a distributed database, you really do want to start rethinking some things. What would I tell you? Like Aurora, you're right. Well, it's pretty much Postgres, right? And of course, you can migrate it over because it's a relational database. But what if I said, hey, you have to run on your on-premise data center, like Savvis around the corner, and oh, we also need to run in Azure at the same time with the same database. You got very little choice at that point. And this is actually where a lot of Cassandra users are right now, is running in two different data centers that are like, one's a cloud and one's my on-prem. We're migrating. Or Sky, who's one of the logos back there, they run in Google, Amazon, and on-prem. Active, active, active. And they have this, there's a common microservices tier in each one, and they all access the same data, which is fully replicated between those three data centers. So this is the kind of reality we're working with. And then how do you migrate your relational data into that? You're going to rebuild a lot of stuff. Yeah. Anybody else? All right. Well, thank you very much. I appreciate you being here. Goodbye, everyone from Twitch.
All 16 of them.
16? Yeah, well, I thought there might have been somebody from the space shuttle or the International Space Station.
Next time.